Okay, guys, it's Kennedy at it again. Now, today we have a very interesting topic on the board called hybridization of atomic orbitals. This theory was developed by a man called Linus Pauling. Linus Pauling. Yes. So it was developed by this man. He's an American chemist. The man is an American chemist. So he developed this theory to explain the structure, that is the molecular structure of covalent substances and also coordinate covalent substances. Okay. Well, what I mean by coordinate covalent substances is that they are these substances that the bond that exists in the substance is coordinate covalent bond or dative bond. Okay. So now, before delving into this topic, it will be good to define what we mean by an atomic orbital. You know that the current atomic model, now that is the atomic model that we use today is the quantum mechanical model of the atom, or we can call it wave mechanics model. Okay. Or wave mechanical model of the atom. So this model is it holds that there is a region around the nucleus of an atom called an orbital, where there is a probability of finding an electron. Okay, that is the wave mechanics model. So now, as the consequence of this model, there is what orbitals of the atom. So there are 4 orbitals of the atom. We have the x orbital, we have the s orbital, we have the s orbital, we have the p orbital, we have the d orbital, and we have the what? F orbital. Now, these orbitals, they have shapes. So this one has a complex shape. This one is spherical. This one is dumbbell shape. This one is double dumbbell. This one is complex shape. This one is complex. So this one has direction, this p orbital. So this is p orbital. So if you want to draw these orbitals, you need to, first of all, you define the 3-dimensional axis, okay, of 3-dimensional space. So this is the x, this is y, sorry, this is y, yes. Then this is x, yes, this is what? Z, yeah, this is x, y, z, yes. So this is the py orbital. This is the px orbital. This is the pz orbital. Okay, so they are all perpendicular to each other. That is, px orbital is perpendicular to py orbital, and the py is also perpendicular to what? Pz orbital. Now, this is the shape of the p orbital. This is the p orbital here. This is the orbital. Okay, it consists of 3 orbitals. Okay, so this is the p orbitals. These arrows represents electrons. Okay, that is the opposite spin of the electrons in each orbital. Now, this is the s orbital. The s orbital, it has a spherical shape. This is y, this is x, and this is what? Z. So this is the x orbital. Okay, this is an electron cloud, like this one. All these things, they are all electron clouds in this orbital. Okay, because here we are dealing with the probability of finding an electron, okay, in the orbital. Correct. So now, if an atom wants to form a bond, that is, when an atom wants to bond with another atom, do you know what happens? As they are coming closer, their valence electrons will be repelling each other. That is, the valence electron of one atom will be repelling the valence electrons of the other atom. Okay, and at the same time, the nucleus of one atom will be attracting the electrons, the valence electrons of the other atom. You know, the nucleus of an atom is positively charged. And also the nucleus of the other atom will also be attracting the valence electron of the other atom. Do you understand? So when this thing is happening, when they come close enough so that their orbitals, their valence orbitals will overlap, that is, there will be an overlap of the valence orbital. You know what will happen? The energy of the two atoms will do what? Will decrease. Do you understand? So it decreased because the energy of the valence orbitals, that is the valence orbitals, the energy of the valence orbitals or the bond orbitals, is lesser than the energy of the atomic orbital. That is before they came closer. Do you understand? The energy at that bond orbital, that bond region, the energy is less than the energy of the valence orbitals before they come closer together. Then when there is a decrease in energy of the two atoms, a bond is what? Formed. Do you understand? A bond is what? Formed. Okay? Now, the more the energy of these two atoms decreases, the stronger the bonds are. Do you understand? It will be forming stronger bonds like electrovalent bond or covalent bond. But when the energy decrease is low, it will be forming a van der Waals bond, okay, a weak bond, a weak intermolecular force. Do you understand? So this is what actually happens. So when the two orbitals overlap, they form a bond. When they meet, they form a bond. Let me tell you what I mean. So this is the hydrogen 1s orbital. This is the hydrogen s orbital with one electron. This is an electron cloud. This is the nucleus. Now this is, let's say, the p orbital of let's say fluorine. So let's say when these two orbitals are coming, so what will happen? There will be an overlap of orbital. This is the nucleus. Okay. There will be an overlap of orbitals. Now see what happened. Now this is the x orbital of hydrogen. Then this is the p orbital. This is the p orbital of fluorine. Now when they come together, you see this region. You see this region now. This region between the two orbitals. See this region now. This is where the bond orbital is. Now the nucleus of hydrogen will be attracting the electrons in this bond orbital, and also the nucleus of fluorine will be attracting electrons in this bond orbital, in this bond in this region. Both nucleus will be attracting electrons in this region. Do you understand? So that's what I'm trying to tell you, that when the energy, as they are coming closer and closer, the energy of both atoms will be decreasing. Do you understand? Because the energy of the electrons in this bond orbital is less than the energy when they are not bonded. That is, when they have not met with each other. So this is it. So in my next video, I will talk about hybrid orbitals. Okay. I will tell you now that when they come together, the atoms, especially the central atom, will now form what hybrid orbitals. Do you understand? After forming the hybrid orbitals, then there will be an orbital overlap leading to what? To a chemical bond, which can be covalent or coordinate covalent bond. So see you guys in my next video.